Okay, let's start today's class. Before we begin with the quizzes, let us just pray first. Turn on your camera. Wait. No. So I will ask Farrell. Please, Farrell, lead us in prayer.
Dear God, now I want to start the math class. Please bless us and Mr. Martin so that he can teach us well, and please bless us so that we can understand what he has to say. Thank you, Lord. In your name we pray. Amen.
Amen. Thank you, Farrell. Okay, so let's start the mini quiz. Please click on the link that I have shared. And this one, I just give you 5 minutes. Okay, only 5 minutes. Okay, the other, please wait. Okay, we need to be complete. Okay, so let's start 5 minutes from now. Good luck. Take your time. You still have more than 2 minutes. But again, of course, you can just finish it. 1 minute 30 seconds. Okay, last 50 seconds. For those who have finished, you can prepare also the textbook and the notebook, and also the latest homework if you want to ask or confirm something. 30 seconds to go. The last 10 seconds. And okay, so you can all back to the Zoom room and turn on your camera. Let me ask you, is there any question to confirm the homework or the mini quiz? Or yeah, Kay, please. And Ariel, later, Ariel. Yes, Kay.
I have a question about the quizzes, Mister. For the question about the true or false, the statement is log to the base of x y equals log y divided by log x. How do I solve it, Mister? I do not know.
Solve it.
It seems false, but then
that is
I don't.
one of, if you still remember, the one that wait, log
To the base of x.
If I'm saying this one. Okay, so actually this one, x equals log to the base 5 of 7, right? So the thing is, you want to prove, is it the same with log 7 over log 5, right? That is what we want to prove. Don't forget that, yeah, that is the thing that, don't forget yang this one, then k equals 5. So k equals log 5. The thing that we have done for like this one, the homework, and then you know that 10 to the power of kx equals 7. Therefore, kx equals log 7, and x equals log 7 over k. And don't forget, we have the definitions of k before log 5, so it is log 7 over log 5. So yeah, that's how.
It's true.
Okay. There are, I don't know which type. There are some types that I mix the, it depends. It depends. So there is a type that I reverse the order. So I don't know which part, which one is that's yours.
Okay, Mister.
Okay. Okay, so yeah, based on
there's
this
so
one,
much definitions, Mister. Sometimes like there's like so many positions that we need to memorize.
Yeah.
Like from the definitions.
Yeah, that's right. That's why you need to be firm with the definition, since now we are learning about the properties. So yeah, I hope you can catch up with that. Okay. So yeah, that's the point. Okay. So I want to remind all of you who are still meddling with the definitions. Well, you need to do it fast, just now to master it, since the properties will make it much more complicated. Okay. So yeah, Ariel, your question?
No, I don't actually have a question. I think like I accidentally raised my hand or something.
Oh, okay.
Like I wasn't raising my hand, but
okay then. Okay then. So one more thing. Log x 36 too. Let me ask you. Anyone? Yeah. Can you figure out what is the x?
6.
Backwards.
6. Okay, how do you do it?
Maybe is that
How yeah. How do you do it? How do you find 6?
x to the power of 2 equals 36.
Good. Okay. Again, I remind you on the instruction later, whenever you have this kind of situation and the instruction says that you have to convert into the definition of logarithm into the exponent, it means you have to do this. That is mandatory. Okay. But again, if we refer to the structure or the rules of algebra, actually the answer is plus minus 6. Right. So actually, the solution set is negative 6, 6. Right? But there is a specific mention before that the base must be greater than 0 and the base cannot be 1. That's why if you are questioning this, we have only one possible answer because the base cannot be negative. That's why we need this statement, okay, to provide us a limit of our answer. Okay, I just want to explain why in your textbook and on my video, it's very imminent for you to know, like this one, the x must be greater than 0, right? And then the x cannot be 1. And which one that cannot be negative also? Anyone? Is it y or z? Which one that cannot be negative?
Z.
No. Why? Y must be positive. Why? Because y is the result of your what is it? The z, look. The z can be negative. Why? Because if I use this 2x equals negative 3. Can we find the x? Well, x will be equals to 2 to the power of negative 3. It is 1/8. Okay. But this one, the argument, let me just flip the textbook. Okay. That's why I really want you to to very clear about the definition. That's why it's included in the textbooks and on the video. It is important. Okay, it is important. So yeah, only the argument and the base that must be positive. The result can be any number. Okay, and then why it cannot be 1? Why the base cannot be 1? Look, if I have this and this, in algebra, we only expect one possible answer if the question is not solution set. You have to find the exact value for this one. Give me the answer then. Who can give me the answer for this one? Log 1 of 1. Log to the base 1 of 1. What is the answer? Anyone wants to give an idea? Flavia?
The possible answer.
Yeah. It can be 6, it can be 7, it can be 5, right? It can be negative 3. So that's why we established rules of the game that the base is not acceptable for 1. Oh, no, not undefined. 1 to the power of what? To become 1. So to becomes 1, you have to find logarithm is the exponent, right? So what is the exponent? It can be 5, it can be 6, it can be negative 3, it can be negative 1000. All our exponent will give you 1. That's why we don't accept the base as 1. So there is always a reason why we give the rules. Okay, so yeah, any questions so far? I just want to add, the importance of the definition. Anyone?
Mr.
Okay.
I just want to make sure the homework in the Google Classroom it's stated as 2 until 12 and then the other numbers and then you said like even numbers only.
Mhm.
Is the even numbers only like 2 until 12 kayak juga even numbers only or do we do like 2
Oh.
until 12 and then even number is the next
It's
section?
all. Oh yeah. Okay. I will try to be more careful. So it's only even numbers only.
Oh, okay. Thank
Yeah.
you, Mr.
Welcome. So yeah, any other question regarding the homework before we go to the properties?
Mr.
Yes, Kay.
For the answers, how many decimals should we write? Minimum.
Thousandth,
Thousands.
three digits after decimals.
Oh, okay.
After comma. Welcome. So for example, one more thing. I want to check. This is one of your homework. 1/64. Okay. So Matthew, how do you find the x?
Oh, it's find the x, right, Mister?
Yeah. Mm-hmm.
With -6. Wait, is it 1/64 to the power of -6 equals to x?
One. Wait. 1. Okay. Try to catch up. Okay, I'm kind of worrying now. So yeah, but still, it's your part. Okay, because when we come to properties, I bet you will just confuse, and you cannot blame the logarithm. It's just that you are still not strong enough in the definition. Now, Nicholas, how do you solve this one?
X exponent of -6 equals to 1/64.
Okay, good.
Then
So first, good. This is the first step, mandatory. Okay, always convert into the exponent. Okay, then.
should I continue, sir?
Yeah.
X exponent of x exponent of -6 change into 1/x to the power of 6
Oh, okay.
equals to 1/64.
Okay. And
then x6 equals to 64.
Oh, you do that. Okay. And then
X equals to 2.
how? Now this one that I want to check. Maybe it's obvious, but when I give you more complicated numbers, you are just don't get the clue, right? It's on the video how to solve this one. You raise to the power of the reciprocal, right? So since this is x, and I know that 64 is 2 to the 6th power, and then I have x equals 2. I want you to have this ability. Okay, so yeah, it's on the video. So although it's obvious, Nicholas, but I want you to train and practice the method like this one, since you have to be prepared with the more complicated numbers, because of course I want to assess the definition, the exponents, and the properties. Everything will be assessed. Okay, so yeah, as long any questions, this is actually on the video, it's number explanation numbers 3. I think the last one. Okay. So yeah, any question? No? Very good. Before we go to the properties, wait, one
Oh, Mister.
more thing. So because yes, yeah, please.
No, it's
Yeah.
actually more of like just a simple question. Before you told Kay that we should answer to like at least no to the thousands decimal, right? So that's
Mhm,
3 digits behind.
mhm.
And then after that we put dot dot dot. Like that's what because that's what the example of the book does, right?
Oh, that's okay because actually I haven't mentioned the expected, but it's okay.
Okay, because my question was like if we use dot dot dot, is the last digit rounded or just like that? You know.
Actually,
But okay.
you cut in the middle. You don't round it. Actually, you just like cut it. No, it doesn't
Okay.
matter the number after the digit after. It doesn't matter. So it's just you
Just cut it.
cut it.
Okay, okay. I see. Okay.
Okay. So whenever you have this one, if the instruction I want you refer to instruction again. No objection about the deduction. If the instruction is solve it by definitions of logarithm, so you have to convert it into exponent. So although it's obvious, but if you have to use the definition, it means you have to convert first into exponent. And then you do the same thing with the exponent before. So x equals 2. That's how you do it if we use the definition. Okay, so be careful. We have, of course, we have many methods to solve this one. So that's why the instruction will differentiate the method that you use. Why we need instruction? Because we have to assess all of the methods that we have learned. So you are not stuck with only one thing. Okay. Yeah. Last chance. Any questions regarding the latest homework? We're good. Okay. So here's the thing. Now here is the properties. So today I will teach you the main properties, the foundations. There are three. Okay, there are three properties. Tomorrow we won't have meeting. Okay, use it well to learn about the other 8. So the other 8 comes from these 3 actually and definition. So actually, without I am teaching you the 8 properties, you can figure that out by yourself. That's why you need to master the 3 first. Okay, the first one, okay, it's actually taken from the textbook. Let me just flip it for you. It is from page 276. Page 276. Now, this is the first one. Okay, logarithm of a product. Before I go, now, I want to make this kind of approach. I want to do the exponent first. Okay, if I have x to the power of to the a power, multiply x to the b power. Kevin, can you simplify this?
X a plus x to the power of a plus b.
Good. Therefore, don't forget that exponent speak about logarithm. Therefore, see, log of a, oh, sorry, the base is x, right? Log x of a times b equals log x a plus log x b. Okay, I want you to relate the first statement and the second. They are all actually the same. It's just different form. So are we learning new properties? Actually not. We are using the same properties with the exponent, but it's just different language. Okay, so the a times b, you can separate this single log. This is a single log. This is a single log. You can separate it into this and this with addition. Don't forget. So let me give you a reminder. Okay. log x, log to the base x of a times b, it's not the same with log to the base x a times log to the base x of b. You cannot distribute log. Log is not a number of variables. No, it doesn't work that way. So in the end, if I have log to the base x of a plus b, it's also, you cannot distribute log to the base x a plus log to the base x b. No, you cannot do that. Okay, so you only can use the first property, and I want you to master both sides. What does it mean? So I want you to master from here to here and the opposite from here to here. Let me give you an example. So if I have log 5 of 3 plus log 5 log, by using the first property, it is 3 times 7. So it becomes log 5 of 21. So we are using from right to left. Okay, so I have an addition between two logs with the same base. Therefore, I can combine it into a single log, but the argument is the product of the previous arguments. Okay, and then if I use the opposite sides, so from left to right, this is the example. Log 7 of 45. Now, we can have variations here. If I want to separate this, I know that log 45 is 5 times 9. Therefore, I can separate it as log 7 to the base 7 of 5 plus log to the base 7 of 9. But I still can do this also. 45 is 3 times 15. Therefore, I can separate it this way also, plus log to the base of 7 of 15. Mr. Kok beda? In the end, if you use calculator and try to add to sum these two different statements, it will give you the same answer. Okay, so that's why logarithm is kind of tricky, because actually in one problem, each of you can have different approach. Each of you can have it. We have the flexibility here. In the end, it will refer to the same answer. It will guide you to the same answer as long as you follow the properties. Any question? So yeah, Flavia.
Can it be like log to the base of like 7, 5, and then yang atas, the log to the base of 7, 9 is like divided again into log to the base of 7, 3 plus log to the base of 7, 3. Like, does it still have the same answer?
Log to the base 7, 3. We are using the first example or the second example, sorry. Flavia.
The second one.
Okay.
The log 15, log to the base of 7, 15. Can it be like distributed again into like log 7 to the base of 7, 5 and log to the base of 7, 3?
Absolutely. So actually, I can still continue with this log 7, 3 plus log 7 of 3 plus log 7 of 5. Good, because 15 is 5 multiplied by 3. Yeah, you can do that.
Thank you.
But again, we are not simplifying here. Okay, we are not simplifying here. So we are making things complicated here. So it depends on the instruction. For now, you have to master the weapons. Okay, so yeah, I like to use the analogy of weapons. So whenever you are going to the battlefield, you're ready to use anything that is provided for you. So now, any other question? No, we're good. Okay, let's go to the second. Please unmute yourself if you have question. Let's go to the second property. The second property, okay, let me, I will use the different base, okay. Y, I will use Y, and then let's use C divided by Y D. Okay, Rafa,
It's YC minus D.
thank
About
you. Yes, therefore it's almost the same. So for two logs with the base Y and the argument C, sorry, the argument is C over D, you can separate this into log to the base Y of C minus log to the base of Y to the base Y of D. Okay, so I want you also to master both direction here and from here to here. Again, I want to remind you, reminder, log to the base of Y, C over D is not the same with log to the base of Y of C divided by log to the Y to the base of Y to the base Y of D. It's not the same. Okay. Remember the translation. The translation is, let me just go further. The translation for this is, what is the exponent Y to the power of what to have the final answer is C over D. This one is what is the exponent Y to the power of what to have C as the final result. And this one is Y to the power of what to make it D. So they are all speaking different numbers. You cannot just combine it, collide it, just whenever you want. Okay? Any question? I will give you example now. Example. So, for example, if I have log, I will use the opposite first. So if I have log 5, 10, no, not 10, 15 minus log to the base 5 of 3, it will be equals to log to the base 5 of 15 over 3, right? And then I can simplify it as log to the base 5 of 5, right? Anyone wants to know? Who knows what's the exact value of this one? Log 5, log to the base 5 of 5. You can unmute yourself.
1.
1.
1. Yes. See, you can come up with an exact value from this logarithm. Logarithm 5 to the, so it's just like a complicated numbers, but in the end you can have 1 just using the properties. Okay, so that is the first thing that you need to learn from properties number 2. And the second one is the opposite. So for example, if I have log 7 of 3 and I want to make it complicated, yes, I can, because 3, for example, is a division between, for example, 6 over 2, right? 3 is 6 over 2. So I can separate it into logs to the base 7 of 6 minus log to the base 7 of 2. Can I do the other things? Of course, I can have many variations here, right? 30 over 10. So I can have log to the base 7 of 30 minus log to the base 7 of 10, and many more, many more. So again, stick with the properties, and then you can be flexible to approach to the problems that you will solve later. So far, any question? We only just covered 2 properties. And after that, the last one, Remember, tomorrow we will have another 8 properties. Can you imagine? So now can you catch up with the definition first before you are going to be confused. Any question? No? Okay, one more thing. The usual mistakes is you remember it incorrectly. So don't forget, another reminder. So it's not that if I have this, I can separate it into C over D. No, okay? Don't make up. So we only have the division is inside the argument, and you can separate it into subtraction, but not subtraction as your argument, and then you can separate it and into division between two logs. That will be not the same property. Okay, I hope that you can take this one. Okay, usually the mistakes is like this, and don't forget, sometimes I just give these kind of problems just to check whether you are mastering the properties or not. Okay, and the last one, it's quite simple. Actually, you have already done your homework number 46, and you can understand why we come up with all of this. But the last one is this. If I have log x a to the power of multiplied by log to the base x of a. Okay, that's all. So for example, I have log 5 to the base 5 of 49, for example. It will be the same with log to the base 5 of 7 square. It will be the same with 2. So this one goes to the front, multiplied by log 5 of 7. So don't forget that this one stands alone as a number. This one also stands alone as a number, and they are multiplied. Sometimes you forget about the multiplication and you just don't know what does it mean move to the front. Okay, so let me just give you example about, oh, okay, that's all. That's the only example actually. Just for your, so for example, and this is consistent with this. Okay, based on definition, 10 to the power of what? You will have 1000, right? So based on definition, actually, we know that the answer is 3. Log to the base 10 of 1000 is 3. But if we use the third properties, we know that log to the base 10 of 1000 equals log to the base 10 of 10 cubed, right? And using the properties here, I can move this to the front. So it is 3 times log 10 of 10. Log 10 of 10 is 1. So it is 3 times 1, it is 3. Consistent. That's why we accept all of these 3 properties. They are all consistent to each other. Okay, and you can get a glimpse about how variative that you can do to solve or simplify just a number of problem in logarithm. Okay, so far, any question? So that's the 3, and that's the most important 3 properties. Because for the tomorrow 8, actually, if you just forget the properties, you can derive it from these 3 by your own. Okay, so yeah. Any question? Very good. So let me explain about the homework. So the homework, for example, page 278, you are given log 2 almost equals 0 point what? Oh, sorry, 301. And log 3, it is 0 0.477 approximately. And log what? 5, it almost equals 0 0.699. Now here's the thing. The question for the homework, log 4, okay? Remember, the temptation is you use the calculator and just find it yourself, and that's not the case. I don't want you to do that. Practice yourself to do the properties. How to do the properties? We have to approach. First, log 4 equals log 2 times 2, right? So log 2 times 2, I can separate it into two different log with addition. And since I know that log 2 equals 0 0.301, so I can have 0.301 plus 0 0.301, it is equals 0 0.602. That's how you find the log. That's how you show the steps. Or I can use the third properties. Log 4 equals log 2 square. 4 is 2 square, right? Because the third property says that the exponent here can move forward. So it is 2 times log 2. So it is 2 times log 2 is 0 0.301. In the end, it is 0.602. The same. Okay, that's how you do with your homework. And again, the homework just provides you practice to master this. Yep. Okay, so yeah, I don't really care how you do your homework, whether you copy it or not. In the end, it will be reflected on the assessment. So now log, for example, log 15. How about log 15? So you have to direct this log into either 2, 3, or 5, since we only know about log 2, log 3, and log 5, right? So since it is log 15, I know that 15 is 3 times 5. So I can separate it as log 3 plus log 5. So it is equals to 0 0.477 plus 0 0.699. And this one, of course, if you want to make it faster, you can use your calculator. It's okay. It's okay to use your calculator in this point, in this step. But do not use your calculator from the beginning. Why? Because you need to practice. Okay. The last one, log 3000. Okay. Let me ask you, Scarlett, how will you approach this one?
Log 3 times log 5 times 2 times 1000.
Wait.
Log 3
Okay.
times 5 times 2 times 5 to the
Times 5
power.
times 2 times 5 times 2, right?
Yeah.
Because this is 10, this is 10, this is 10. 3 times 10 times 10 times 10, it is 3000, right? So yeah, in the end, you can really know that this is log 3 plus log 5 plus log 2 plus log 5 and so on. Okay, you can do that, of course. But I want to remind you, actually, you can do it faster. Log 3000 is log 3 multiplied by 1000, right? So it is log 3 plus log 1000, 1000. Log 3 is 0 0.477. Don't forget, actually, log 1000, the base is 10. Because the base is 10, 10 to the power of what? It becomes 1000. It's 3. So you can just directly use this and you have the same. I bet you, if you use the long one, like what we did together with Scarlett, it will give you the same answer with this one. Okay, so again, do not be afraid to be wrong. It's just a matter of which is longer and which is shorter. Okay, but whenever you submit to the 3 properties, you are safe. Okay, that's how you do the first batch. And the last one, sorry, last one again. Jadi, the first batch is to practice you how to separate the log. The second batch, how you combine the log. So for example, it's 3.5 plus log 3.7. The objective is to make it a single log. How to make it a single log? I want you to understand that actually you can do this. It is 5 times 7. So it is equals log 3 of 35. Now this is called a single log. Before we have 2 logs and we convert into a single log. See, again, using the homework, actually you will have enough practice. The reason, the situation is whether you really want to understand it or not, okay? Whether you want to use it well for your own benefit or just a formality. Let me just stop here. So again, on Friday, we'll have to quiz. The material will be up until tomorrow, only the properties and the definitions. So you still have a lot of time to master the definitions before the properties is given the 8th tomorrow, and practice by doing the homework. And on Thursday, I don't want to give you the simulation because I want you to respect the homeworks that you have done. So everything that you will have done on the homework, it will be there on the quiz and on the test. Okay, so learn from that. Last chance, any question? You're good? Okay, so yeah, you can be dismissed. Thank you for your time and attention.
Thank you, Mr.
Thank you, Mr.
Bisa.
Martin.
Welcome.
Thank you, Mr.
Welcome, Nick.
Mr.
Alzena?
Can I have the recording from
Okay.
today?
Okay.
Although, Mr. I think I'll just use quizzes in tablet.